Good morning. Thank you for coming in such a number. You guys who are waiting, standing there, I guess you could come and sit in the front if you wanted. It would be very uncomfortable, but probably better than standing. Thank you for coming. My name is Jerome Daucher.
And my name is Nicholas Behrens.
And we are from Google in Mountain View, California. We both work on the Gmail front-end server in Java. But today we're going to talk about the effective dependency injection. And this is the agenda for today. We firmly believe that the talk today is around dependency injection, which means that it's pretty much framework agnostic. Even though we are most familiar with Juice at Google, we will use Juice to give you examples of the items we're going to go through. But I think that you should be able to transfer this into your favorite other frameworks if you want to. So the purpose of this talk is really to give you some guidance about how to write applications using dependency injections, because all of the other talks that I've seen out there or books, they really give you very, very little guidance about the patterns of the things that you should do and the things that you should probably not do. And some of the things that we've learned very, very painfully at Google while trying to use Juice in Gmail. So we're going to start with a refresher. I sincerely hope that most of you know dependency injection by now. If you don't, it's going to be a little tougher for you, but we're going to refresh your mind right now to get you started. So remember, dependency injection is all about declaring what you need and not exactly how to get it, and hope for something above you to provide you with your dependencies when you're just about to be put into a working environment. And so here you've got an example of how you would want to have a constructor with injecting maybe a credit card service. And you could see the old way of doing things where you would have a reference to another service and you would have a direct reference to it on how to obtain it. And that was painful in the past because that would wire your application very statically, and it would make testing very difficult because it would be impossible, for instance, to replace the risk accessor with a mock version, or it would be difficult to replace it with a less secure version. All this kind of stuff would be completely statically defined in your code. So with dependency injection, you just rely on the system to find the right version at the time of execution, and then you can just run with it. So it's giving you loose coupling. We've seen all this among the years. Now, it's reducing a lot of complexity, but because it's reducing complexity and is providing a lot of flexibility, you can really shoot yourself in the feet or in the foot. It's something that we've learned painfully, as I said. There's many frameworks with very many tools, so it's important to establish good conventions in your project and stick to them. And some of the conventions we're going to show today is what we've learned. Some of them, are more or less coming also from the Effective Java, the book that Josh wrote many years back. And so sometimes we mix the two together. It's important to establish those conventions inside your project so that you can have the similar failure mode between your different engineers on the same team, and you have a consistent way of providing code for the project, which is something we really believe at Google. So most of the DI frameworks out there, they will provide you the ability to create objects, factories. So that's how the providers. And the simple version of a provider is really to be able, for instance, to create an object from calling its constructor. That's probably the simplest one. There's some more sophisticated version of providers, which depending on maybe flags, runtime environment, will decide which version of a particular service it should instantiate. But basically, at the core of it, the producer is responsible for providing you an instance of a service at the time you request it. Now, these producers, they are being bound. This is through a binding, where you basically declare to the framework that, for instance, a certain service with a certain interface is available for consumption by anyone. And this service is identified by attributes. The most common attribute, of course, is the type of the service. But there are also other attributes, for instance, things that we call binding annotations, which will define which of the what you want to declare as being provided. So, for instance, you can have a synchronous and an asynchronous version of the same service, and you would bind the two, one with an asynchronous binding annotation and one with a synchronous binding annotation, and depending at the injection time, depending on what the user is requesting, you would bind one of these two. So this binding provides you these injectable resources. Now, the @inject provides you the injection points. This is where those injectable resources get injected into the components. And again, it's important to realize that same as for binding, @inject has attributes, and those attributes, they can be binding annotations again. So you can have @inject, @async, for instance, as the binding annotation, and then the name of the service, or the type of the service. Although it's possible to reuse bindings independently, most of the people consider module as being the unit of reusability inside dependency injection frameworks. And so you compose all these bindings together inside a module, and you try to minimize the output of the module, the exported interface of the module, which is the bindings that you've offered through the module. And you try also to minimize the things that you need to import for this module to work properly, right? So the module will define a set of exported interfaces and will also require a certain number of interfaces to work properly. When you start composing modules, you have what we call an injector. So at that time, you better have satisfied all the injection points. So you must have at least one injectable resource for every single injection points. You can have more than one, but probably only one will be picked up. But you need to have this all set up by the time you created the injector. So the injector, in a sense, is one per application, although we'll see at the end that when you deal with old code that you try to juicify or to introduce dependency injection into, you might actually have more than one injector inside an application. Something also to understand before we get started is scoping. So we talked about these injectable resources. Those are objects at the end. These are Java objects. So how long do they live? Who stores them? Where are they stored, right? And so these are governed by the scoping, right? So you've got different scoping in Juice, for instance. For instance, you can have a singleton scoping where the life cycle of the object will be started when the first request for injection happened, and it will not get garbage collected until the actual application shuts down, right? So it's a singleton object. Some more complicated one can be request scope, where basically you have an object being created when an HTTP request comes in, and it will live through the HTTP request lifecycle, but once the request is committed back to the client, then the object is garbage collected. Or you could have objects which are instantiated each time somebody is requesting a version of that service, so it's a pair lookup in a way, and that is probably the safest way because you don't have to share, you don't have to worry too much about synchronizing these objects if you can deal with containment. So scoping is important, and we'll talk about how you can use that through refactoring existing code. So let's get started. I hope that you all know about the dependency injections, and we're going to start with our first item. We're going to start simple, and then we'll get more complicated as we go along. The first thing that I would like to emphasize is the importance of providing explicit bindings. So, you can have implicit bindings when you define juice components, and this is very, very convenient at the beginning, but we've learned painfully that it can really bite you. In particular, relying on implicit binding will be dangerous when you remove an explicit binding. For instance, we had a case where there was an explicit binding for a particular component. It got removed. Suddenly, the system continued to work because it relied on a different binding, which was an implicit binding, but with a different scope. And the system just continued working at the beginning, but then it really went sour from there, and we had a lot of issues. Another even more dangerous issue that can arise with implicit binding is when, say, you pull a new module inside your application. So you add a new module, and that module is providing you an explicit binding for this particular component. So up to now, you were using an implicit binding of something else. Now suddenly you bring a new module which has an explicit binding. All your application is going to start using that new explicit binding. So that means that your entire application is using a new version of a particular component. And that's an extremely dangerous situation to be in, obviously, because you basically run with an entire new set of services. So Explicit is always better. It's even more true with dependency injection. It's important that you do an explicit binding, even if you just do, like in this example, just a documentation binding, where basically you're binding an implementation class into the abstract module. It's not very useful for Juice, but it's very useful for you as a documentation and to provide these explicit bindings. Second item, inject exactly what you need. It's obviously something that comes from object-oriented programming, right? You should probably not do this, even if you are not using Juice or any other dependency injection framework. In this particular case, you just inject user to be able to get to the account. Most of the frameworks that I know out there do provide you the ability to have a provider method that would take a user as a parameter and would return the account. So you just create a third method here, which is going to provide you the account from the user, and you write the payment processor to just take the account. That allows you to write better testing, because you don't need now to write a mock for user and write a mock method that will return an account for that particular user and stuff like that. So it's much cleaner. So it's important to really inject what you need and avoid having these very complicated dependencies that you're actually not using at all, that you're going through to basically get to the object you're really interested in. I think it's true.
Right. So the next few slides here are going to be around constructors. So constructors are obviously a very important thing when we're talking about dependency injection. Prefer constructor injection. So many frameworks allow you the opportunity to use different kinds of injection. So field injection, method injection, or constructor injection. We've settled on the pattern of using constructor injection exclusively. One of the great benefits of this is it allows you to have all your fields that are storing the injected services to be private and final. So with setter injection, like setters on your fields, or field injection, you often need to make them non-final. This has nice side benefits for things like immutability and thread safety. It's often a lot easier to make your class thread safe when the majority or all of its fields are private and final. The constructor injection also has this nice property of that your objects are valid post-construction. You don't need to worry about some kind of method needs to be called sort of implicitly, some set the service or initialize after you've constructed your object. That'll hold true also in your test. So when you create your object in your test, you're done. You don't need to worry about calling some additional setters. And the last thing here is that it matches developer expectations. So in the non-DI world, as you have people coming over into dependency injected code, they don't need to worry about these other methods or special ways objects be constructed. It's very similar to standard object construction. So another pattern here we recommend is to avoid doing work in your constructors. This is also sort of a general good thing, but is especially true with dependency injected code. So it's great for separation of concerns. We want to separate your wiring up of your object graph from doing actual work to sort of initialize your application or initialize those objects. It facilitates testing, so you don't need to worry about when you want to create your object under test in your test code. You don't need to worry about sort of side effects happening as you're trying to instantiate the object. And this really leads to sort of the standard constructor that you'll have. In the vast majority of our code, all of our constructors look very simple and very straightforward. You just have sort of all your dependencies being declared as constructor parameters, and then all they are is just assigned to private final fields. In Juice, doing work in your constructor can lead to some tricky issues. So if your constructor throws some kind of exception, Juice or your framework will wrap that into this runtime provision exception, which can easily sort of bypass your normal try-catch flows and propagate up to the top of your app. So what do you do with work that you might want to be doing in your constructor otherwise? One suggestion is to do the construction of the object graph first. So you go through and sort of get a handle, create your injector, get a handle on sort of your top-level app object. And then after you've sort of done all the construction, you can do some explicit initialization step. So you could ask the injector for some app initializer and then run the initialization and then start your server. All right, so there are some cases though, and oftentimes for like legacy code or you're trying to bring dependency injection into some code, if you have to do work in your constructor, one example we have here is, and this is juice specific, is using check providers. So this would be the syntax where you declare that, I have these sort of special providers that can throw some kind of exception, and they can throw multiple exceptions. You can declare whatever you'd like there. So once you've got this data store provider, you can then write these special provider bindings where you say, okay, so when I actually want to provide something like, in this case here, we have some contacts being provided from the user store or data store. That provider method, which would normally not be able to throw an exception, or if it did, it would get wrapped in some kind of provision exception, can actually throw this checked exception. And then the key piece of special sauce down there, that install throwing provider binder for a module, everyone forgets that like at least once. If you forget that, the whole check provides thing doesn't work in Juice, so be careful about that. And then now that you've got this data store provider for your contacts, you can then inject it just like you would inject a provider for any other type. And at runtime, calling get will potentially throw your checked exception. So obviously this is a little more complicated. There's quite a bit more logic that goes into doing the bindings. There's that special syntax where if you forget to sort of set things up correctly. So definitely more complex, more verbose bindings. It creates more setup work for tests, which is kind of unfortunate. You can't just sort of inject the service that you need for constructing your object. You need to sort of wrap it with something that implements that data store provider interface. Also has the potential problem of sort of allowing business logic to creep into your provider methods and into your bindings, which is something we also discourage. And then it tends to sort of be viral in the sense that once you start having types that can throw these checked exceptions, anything you sort of, any other objects that depend on that or their construction depends on that service tend to also become those kinds of check providers as well. So another guideline recommend here is to avoid direct dependencies on the injector. So the top level object that allows you access to sort of all your bound services, it's sort of this big grab bag. One of the nice things about constructor injection or dependency injection is that you get this nice listing in your constructors of sort of all the dependencies of this object. So it depends on service 1, 2, and 3, and I can see it always in a consistent spot. But if you start injecting the injector, now you don't know, right? You have to actually go and then trace down and figure out where we're actually, maybe we assign to a field, and then later on we start calling get instance on the injector in a couple places. You've now sort of distributed that knowledge of what this thing actually depends on. And then it's easy to start using the injector. It's sort of this nice, really convenient, you don't have to sort of list all of your parameters. But it's hard to sort of back that change back out. It's hard to then reverse all that. All right, a couple more things here. Avoid binding very general types. It's possible to bind, simple integers, longs, strings, those kinds of things. And at your injection site, you'll see something like @inject, just the raw integer. This is bad because, of course, it's very likely over time you're going to want to bind different kinds of integers that mean different things, or different strings that mean different things. So the way you would do this in Juice is to qualify your binding with a binding annotation. In this case, we called one, for HTTP. And so now when we inject, it's a little bit more clear about what this integer represents. Sort of along the same lines, you want to avoid parameterized binding annotations if possible. So in the big culprit here is this named annotation, which allows you to sort of pass in any string and then use, it's very convenient to use this at first, right? You can just you avoid having to define these custom binding annotations for each new use case where you need this qualification. But you sacrifice, some safety here. It's very easy to make typos, and you'll quickly, run into trouble there. The IDE can't help you. You'll get more runtime errors. It's harder also to track down sort of all users of a particular binding because you have to, do some kind of like regular expression search on your named injection sites. Much easier if you just do a find references on the for HTTP binding annotation. So if you do need to use them though, recommendation is to try to use consistently. You want to use a fixed set of constants for those binding annotation parameters. Enums work great for this. So for example here, we might, let's say we had a bunch of 4-port bindings for different kinds of ports that our server listens to. Maybe we have a ports enum that sort of specifies all those different ones, and then we can consistently sort of use that as we need to inject. So another principle here is keeping modules fast and side effect free. So ideally, your modules are just collecting the bindings in your application. They sort of centralize the knowledge of how to wire up things, but they shouldn't be doing real work. They shouldn't be making RPCs to services. They shouldn't be reading from disk if possible. You want to make it really easy to sort of pick and choose sets of bindings so you can sort of compose libraries together without having to worry about sort of these implicit costs to bringing them into your app. So some examples of things that you also want that can slow down your modules would be binding to specific instances. So maybe constructing an instance of something is slow. Requesting static injection. Another thing that crops up sometimes is serially initializing like singleton services in your application. So in Juice, you can sort of request in one of your when you create your injector, one of the things you can request is that it go through and call get instance on all your singletons sort of as your app starts up. The idea being that this sort of will speed up the first request when that reaches your server. But this is all done single-threaded. So if you have a lot of singleton services, this can be a big expense. Much better would be to do something sort of an explicit initialization step, which you could do in parallel, right? You could have some thread pool where you go through and iterate over all your singleton-bound objects and request them from the injector, and then sort of block until all those threads are done. All right, a couple more here. So nullable is an annotation that you can use with dependency injection frameworks to say that it's okay to inject a null value. Juice by default won't inject nulls. It'll complain if you try and inject an object that's bound to null at a non-nullable injection site. I think even better than using nullable, though, is to prefer the null object pattern. So this example here, we have at the top, we have this provider method, which is providing a service, this abuse service. And one of the inputs to it is the abuse service to talk to. And maybe when we run the server locally for development, we don't really care about abuse checking, so we leave that flag empty. And so it's saying, if no abuse service is specified, return null for this binding. Otherwise, return the real one. So at our injection site, we need to put nullable on the @inject, or on the parameter. And then at runtime, we need to be careful sort of dealing with that null. The alternative using null objects would be to, instead of returning null up there, maybe you can define a stub abuse service, something that just returns default values that make sense for local development. And then you don't need the nullable down there. And then the do abuse check code doesn't need to worry about checking for null either. All right, so we've mentioned providers in a couple of situations here. There's 2 other things we wanted to just comment on about here. So providers are great for delaying provisioning of code. By default, you could, let's say we have a binding for this abuse service, we could just ask for the abuse service. And so when we ask for it, when it gets injected, our framework goes off and creates the service. Ultimately, we can inject a provider for that service. And so the framework will delay construction until we actually ask, until the first time we ask the provider for the service. One common use case you'll see for this is sort of selecting between multiple services. Maybe we have some old version of the abuse service and we're trying to migrate to some new one. And we don't want to sort of create both of them. We sort of only, based on a flag, want to pick one or the other. So you might see a pattern like this where in your provider you inject providers for the 2 things that we're picking between, and then only call get on them based on a flag or something like that. This way we're only creating one of the services.
All right. Next is about scoping and alternative to context. So I'm going to go through an example of how you can replace what we call a context object with scoping. Context objects have been used for many, many years for many and bad reasons. Sometimes good, sometimes bad. And here is how I describe something which I think I would have been pretty proud to write a few years back. So you've got a pipeline visitor. It's just going to be a bunch of visitors who are going to visit some object and probably mutate that object. Nothing too fancy here, but you can see that the pipeline visitor is very simple at the beginning. It has just the type that it's going to visit as a parameter. And then the pipeline itself is instantiated with the set of visitors that is going to invoke one after the other. And then it also has a visit method that will allow people to launch the pipeline of all the visitors. So it looks pretty good. As I said, I would have been pretty happy with this code a few years back. But then, things move on and the project starts to grow and some new requirements comes in, and then, somebody tells you, oh, well, now we need to have the user being passed to the visitor, because sometimes some of our visitors, they need to know which user is actually requesting this work. And so you do that, and then somebody else come a week later and tell you, well, we would really like to be able to log what's going on in the visitors. So could you also pass the logger so we can have access to the logger while we are visiting? Yeah, sure, why not? And then the week after, somebody else come on and say, well, we need to know what is the context of this work. Maybe there's some parameters that will make the work done, in various different ways, and we need to pass those parameters now as well. And so you can see how, over time, the number of parameters to your visit method is growing. And so you become really more and more grumpy about it, because each time you modify the interface, you have to change all the implementation, plus, of course, the invocation from the pipeline. So it's a lot of work. But, yes, you've got the context object to the rescue. And so you've got this idea one day that instead of passing all these different objects to my visit method, I'm just going to pass a context object in which I'm going to stuff everything I need today, and I will continue stuffing everything I ever will need, and I will pass this context object to my visit method. It's beautiful. Now somebody wants to add a new parameter, you can just modify the context and you're done. And I think I've seen context objects in the Gmail code base that had more than 100 fields. So, it gets out of hands very, very quickly. So what you need to do is to get rid of the context object altogether, is to come back to the original ID where you just had one parameter, and then rely on injection and the good scoping to figure out which parameters or which fields or which services are necessary in each visitor. Right? So you try to separate the concerns about providing all the parameters to everyone, but providing only the ones that are necessary for each of them. And so here, this was the old pipeline. As you can see, I had to create the context. So the problems that we had in this type of coding was, first of all, as I said, the context object is enormous. Then testing becomes really, really difficult, because each time you would want to test a single visitor, you would have to create a context object with potentially dozens of objects inside it. So it's pretty awful. And then the isolation level is pretty bad, right? So the fact that you're passing context objects between these different visitors, they can actually mutate the context itself, they can change it, the order in which they run can then influence how these things is being changed. So a lot of different implicit behavior start to creep up in your code, and then bugs shows up, and it becomes very difficult to debug. So so the first thing is remove the context. Come back to the original type and have the visitor interface just take the mandatory, just the bare minimum parameters it needs to fulfill its task. You could even argue that they don't need to pass any parameters and everything gets injected. It's possible. I mean, there's pros and cons to that. I suppose it's nice that if you know that a parameter will be used by all, to pass it as the parameters to the method is absolutely acceptable. But you can see here that, for instance, the two other visitors implementations that you can find here, they inject what's required for them only, right? So they inject the logger, the other one injects the user, and that's what they can use. Now you can see that the logger visitor never injects the user because it doesn't need it. And conversely, the user-dependent visitor does not inject the logger. So now you can see that you've started separating the dependency of each visitor, and you started resolving these dependencies through an appropriate scoping, and you can now get rid of these awful context objects. The second thing to do is to avoid binding directly the pipeline, the one that runs all these visitors, to the set of visitors. So at the beginning, I don't know if you paid attention, but the pipeline was instantiating each visitor before it would eventually start looping and do the visitation process. Sure, you could have externalized that process and have some sort of factory that creates the pipeline, creates the visitor, and then sets the visitors on the pipeline. But it still remains kind of difficult. You've got a factory now. If you want to have maybe a pipeline that runs with a different set of visitors, you need a second factory, and then maybe now you need 10 variations of these visitors list, and then you then need 10 factories. I mean, it becomes really, really nasty very quickly. So. One of the things they can do with most of the dependency injection framework is to use a multi-binder. So this is the ability to bind multiple objects or multiple bindings to a single interface. And then after, you can use injection of a set of that particular interface inside the pipeline, and then everything which has been bound to that interface will be injected by the framework. So that's very convenient. You can see the syntax here. I'm not going to comment it, but basically you could have multiple modules that use this multi-binding, and you will have the ability to get all the different bindings injected into this set. There is some ordering within a module, but there is no ordering between modules, so you have to be slightly careful if you've got an ordering issue with your visitors. But if you don't, you can just use that facility. You just inject the set, and you can see now that the pipeline has a final list of visitors, of providers, of visitors, and then the code is a lot simpler, right? It's just looping around the visitors and visit them. One of the things which is really great at this point is the ability to then test the pipeline in isolation, right? You can pass to the pipeline a set of mock visitors just to test that the pipeline is behaving normally. So you can test each visitor much more simply, because you do not have to provide this humongous context object with all these dependencies for every single test. You can just concentrate on what this particular visitor is depending on, but also you can test in isolation the pipeline by also giving a bunch of mocking objects as the visitors. So by separating this context and the dependencies, you can really simplify the code and the testing. So here is an example. You can see that I'm testing the pipeline by providing a mocking visitor, and here I can verify that my visit method was actually called properly by the pipeline. So it's a good way for me to test very simply the pipeline code without having to provide or instantiate very complicated objects. In fact, I only instantiate one, which is the pipeline. So much simpler than anything I would have had to do before if I had a context object. Because remember that with the context object, even if you wanted to test just the pipeline, you would still need to probably create a valid context object. Because as you pass the valid context object to the pipeline, you really have no clue if the pipeline itself is using the context, right? You can't rely on the fact it's not using the context. Maybe it's not using it today, but the fact you pass it as a parameter to the method, it's a contract. They can change the code to start using any method of that context, and then all the tests will break. So you can't just pass mocking objects when you start using things like context. Much more difficult. All right, we're going to go into the second part of the talk, where we're going to talk a little more about how you can compose applications using dependency injection. So it's not so much about how do you provide your bindings on stuff. It's more how should you organize your code, and then we'll talk a little bit about how to deal with legacy code. So one of the things that I want to talk about is the impact of dependency injection on modularity. So you want to use Juice or you want to use any other dependency injection frameworks because you want your application to be modular. You want the ability to compose your module, maybe not at runtime, but certainly at build time together, and then have all these dependencies satisfied and have a running environment where you know that everything is going to run appropriately. Now, The best way to do that, in our opinion, is to do a service-based architecture where you define things as interface and implementation, and then you try to hide as much implementation as you can. And then everybody is just injecting interfaces, and then you can replace such interfaces implementations with other. Nothing very, very dramatic here. But these days, you hear a lot about modularity in Java and how OSGI or maybe Jigsaw in the future will actually finally help you doing modularity with Java. And I would like to not say that it's not useful to use OSGI, but you would have to consider what the impacts are of using such a thing as OSGI when you just want to do modularity. OSGI is very powerful, maybe too powerful for most of the people, and really it's only very valuable if you have two very distinct needs. One is runtime extensibility. Say you have a plugin architecture, your Eclipse, for instance, you have a plugin architecture, you want the ability to bring new modules at runtime within your environment, to load new classes, new jars, then you need something like OSGI. Or maybe you have a versioning problem. You may have part of your application using version X of a library, another part of the application using version Y of the library, and nobody wants to be in that spot, but we've all been there somehow. It's something that you may require, and you think that you can't get rid of it. So yes, OSGI will help you doing that. But if you just want modularity, I strongly believe that dependency injection will give you most of what you need without introducing all the complexity of a real modularity system like OSGI. So how can you do that? You just do like you would do in normal object annotation language, right? You have an API, you define an interface. Here is a spam checker. It has one method. Remember that you can have binding annotations and stuff like that will go with that particular interface. So you can define which of this interface should be injected at runtime. And then, of course, you've got an implementation, which most of the time you should make package private. There's really no reason to make that implementation public. You can make it package private, and it implements the interface, nothing special, right? Now, how do you do the binding? How do you build your module out of this? You collocate the bindings with the implementation, right? So you have a public class. It has to be public because it's going to be called by other modules or to create the injector. So it has to be public. You create it within the same package as your implementation, and that's the one that will bind the interfaces to the implementation, eventually using binding annotations and whatnot. Using that will allow you to basically only export the right classes out of your package, right? Use the Java language package private to ensure that your implementation do not leak. You do not need to have something as sophisticated as OSGI to refrain people from using your classes. Java will give you that from the ground up since version 1.0. So to use it in your app, you just install the module, and then you can inject the spam checker. Now you can see that somebody else can come around and have another implementation of the spam checker, and everybody else will be injecting it happily. No difference, right? Nobody is binding to the implementation. So we talked a lot about, okay, so I can provide bindings and people can use me and stuff like that. Now let's talk a little bit also that when you define a module, in particular in a modular environment, it would be nice if you can also implement or declare your dependencies. If you could say, well, my module is exporting these are the bindings, right? But if you could also say, and my module is requiring those bindings to be available to run correctly. So that's not mandatory in JUice. I don't know if all the other dependency injection frameworks provide such facility, but we believe that it is a great help as a developer when you declare your module to be able to specify not only what you export, but what you import, so that you can more easily compose these different modules into this set of jar files that will be used to create the injector. So document is very important, and especially with code, so that you can use all the refactoring and all the code navigation that your IDEs will provide you to find things. So once you've done that, you need to package it. And these days, there's different ways you can do it, but here I gave two examples. So in Maven, although I believe you could just use a normal jar file. You do not have to split it in two. Maven tends to like to have two jar files, one for APIs, one for implementation. And so you can put the interface in the API module. You can put the implementation in the implementation module. It can be in the same package, doesn't matter. And Java package, I meant. And then the API module will be used when compiling, while the implementation can be used when you assemble the application. It's not very difficult. Now, when you do OSGI, it's a bit more complicated, because OSGI is forcing you to either export a package or keep a package private. You can't just say, I want half of this package to be exported or not. If the package is exported, then of course, every single class which is public within that package will be available. So to be able to hide your implementation, in theory, you would need to move these classes into a separate package from the interface. And you would probably need to also have the module in a different package, probably with the API, because it has to be exported from the implementation. So it forces, in a sense, to make those implementation public, because they are not in the same Java package anymore, because your module needs to have access to it. He's the one doing the binding. It's a bit more murky if you want to do it really the OSGI way, but it's certainly possible to use dependency injection with OSGI. All right, I think go back.
All right. So got two more sections to get through here. So we've got some testing advice about how do you test once you start getting a dependency injected code base, and then the last section around applying dependency injection to existing code. So we've been talking a little bit about testing sort of as part of this other stuff, so I'm probably going to breeze through here pretty fast. So there's different levels at which you can write some tests for your dependency injected code. Sort of starting from the ground up, you can write your small unit tests for the dependency injected class itself. There's nothing too complicated here, which is sort of a nice side benefit of following all these guidelines that we were talking about earlier. The test can inject mocks for the services as needed, and they don't have to worry about any side effects of RPCs happening in the constructor, and then call the method under test and sort of verify the output. And then there was a quick code example here of doing just that. So one of the other things you might want to test would be the bindings themselves. Do we sort of have all those bindings, all the required bindings? Are they all being provided? Do we have a coherent set of modules to create an injector? And one of the tools you can use to help create those modules in testing is in Juice, you can override individual bindings in your test code. So it might look something like the sample code here, where you say you want to override this production module with this one binding here, so we can sort of stub out the off checking. This will help with like some problematic issues where maybe you have a dependency on a service that's not available in your unit test. But it can also be a straitjacket over time, where if you have too many tests that are overriding different subsets of bindings, every time you want to change those production bindings, you need to go fix all the tests. So avoid doing this too much. So one of the key things we really think is necessary once you start having a large dependency injected code base are system or end-to-end tests. You really need to have some automated tests that are creating a real injector and making sure your app can start up. One of the things that the flexibility of dependency injection costs you is some runtime failure modes. So having those kinds of end-to-end tests are critical. All right, and then the last section here. Check my time. So migrating to dependency injection. So one of the things we want to communicate here is that it's not an all or nothing thing. We started with a very large code base within Gmail, and we spent a lot of time migrating to dependency injection. So it's possible. You don't have to push it everywhere at once, though it will take time, and it can be very challenging. So some of the techniques that recommend for migrating a code base to dependency injection, you can. There's really two approaches. One is sort of this bottoms-up approach, where you look at sort of leaves in your object graph, and you say, okay, this small little package of code, we're going to get this under dependency injection. And so maybe you create an injector and a module and an injector just for sort of creating that set of graph nodes in your object graph. So you tackle that section, and then you're like, okay, we've got this other section here. This one's pretty clean code, some new code. We'll define a module and create an injector for that, and then we can now use Juice to create those. So you start having a couple different injectors around at the leaves. The other option is sort of to come at it from the top down. So you create a injector at your top level, and maybe the only thing the injector creates is some simple class that wraps like some existing static code or something that's not dependency injected. But you get the injector in place, and so you've sort of established this this frontier where everything above this line Juice is available at, or your dependency injection is available at. And then you can sort of work to push that line down. You sort of start with the things where you see the new calls to explicit calls to constructors, and you define bindings for those. You replace those with injections, and you sort of push the frontier down. Oftentimes, when you're trying to migrate to dependency injection, you sort of need to compromise on a lot of these patterns that we discussed earlier. So, if you're doing a bottom-up approach, you'll have multiple injectors, which generally you want to avoid. You might need to directly reference the injector, so pass it around through methods where it'd be difficult to inject directly. And you may have constructors that do work. But you can use some of the techniques we mentioned earlier around like check providers to tackle those. So the last two things here, two things to avoid if you're starting a new code base and maybe you're going to go to dependency injection at some point, you want to try it out. These are two things that in particular we found made migrating to dependency injection very difficult. So the first thing is deep inheritance hierarchies. At one point, we had a particular nasty set of classes that I think all told there were some 20 or 30 levels in this hierarchy, and trying to get dependency injection around that was just a tremendous challenge. And you can see in the simple example here where we have this base service, maybe a mobile version of the service, and then an Android-specific version of the service. At the most specific levels, you can actually have dependency injection work there. But if at any point in the inheritance tree, your dependencies change, you need to sort of pass those and thread that dependency all the way back up the tree. So this leads to a lot of churn. All your tests have to be updated every time you change the constructors. It gets painful. So definitely recommend to prefer composition instead of inheritance here. So break these out into smaller focused objects and then sort of inject them all into just one class. The other big thing is static methods make things challenging. Dependency injection is all about sort of runtime flexibility or flexibility in sort of how you compose things, whereas static implies a fixed binding, a fixed compile time binding. So this can make it really difficult to get dependency injection around your code. So that's all we have here. In summary, the key message to try and get across here is that dependency injection can really help you write a lot more flexible code, more testable code. It's possible to use it for big applications, but it does come with some costs. We recommend you establish conventions and good patterns for using it, and that'll really help your application work well with dependency injection. We'll hang around a little bit afterwards outside if you guys have any questions. Otherwise, feel free to contact us any questions you have. Thanks, guys, for coming.